Hello scholars, welcome to another interesting video, and today we're going to look at resolution of forces. Now, every force or every vector must be resolved into a horizontal and a vertical component. Alright, every force or every vector is to be resolved into a horizontal component or a vertical component. So now let's look at this. Let's look at a single force. The case of a single force, let's say force F. All right, so this is force F acting at an angle theta to the horizontal component, or to the horizontal. Let's just say to the horizontal. This is a force F acting at an angle theta to the horizontal. Now, we need to resolve this force into a vertical and a horizontal component. So the horizontal component of this force is going to be F cos theta. All right, F cos theta. While the vertical component in this case is going to be F sine theta. Now, do not forget, this force is inclined at an angle theta to the horizontal. So when we're resolving this force to the horizontal and vertical component, it becomes that the horizontal component to be F cos theta and the vertical component to be F sine theta. Now let's look at another case. Let's say the angle is now inclined to the vertical. All right, so this is force F. This is our x-axis, of course. This is our y-axis, and put that here too. All right, now in this case the angle of the force is inclined to the vertical. So as it's inclined to the vertical, now for us to resolve this force, the horizontal component in this case is going to be equal to F sine theta, because the angle of this force is inclined to the vertical. All right, now the vertical component now is going to be what? The vertical component in this case now is going to be what? F cos theta, because the angle is inclined to the vertical. Now let's go ahead and look at a case whereby you have more than two forces acting at a point. Now this is a case whereby you have more than two forces acting at a point. Now let's look at how we can resolve these forces. This is F1, F2, F3, F4. F1 is inclined at an angle theta 1 to the horizontal. F2 is inclined at an angle theta 2 to the what? Horizontal. And F3 is inclined at an angle theta 3 to the horizontal. Also, F4 is inclined at an angle theta 4 to the same horizontal. So now let us resolve this. Now for the horizontal component, I can use x component. This is what is going to be for the horizontal component. Now this F1, right, is at an angle of theta 1 to the horizontal. So what is it going to be? It's going to be F1 cos theta 1. That's, I've resolved this. And why is it positive? It is positive because this is the positive part of your x-axis. This is the negative part of your x-axis. And this is the positive y-axis. This is the negative part of your y-axis. But we are resolving for your horizontal component. All right. So this is at the positive part of your x component, which is also your horizontal component, because you are resolving for your horizontal component. All right. Now let's continue. So F2 now is going to be what? Plus F2 cos theta 2. All right. Don't forget, this is inclined directly to the horizontal, and it's also on the positive part of x. Now let's move to F3. Now this is F3. F3 is inclined at an angle of theta 3 to the horizontal, but it is at the negative part of x. So it becomes minus F3 cos theta 3. Now, the next one is F4. That's the first 4. It's also inclined at an angle theta 4 to the horizontal, but it's at a negative part of x. So it becomes minus F4 cos theta 4. Now, let's see how we can resolve for the vertical component. All right, for the vertical component. Now, this is F1, all right, inclined at an angle theta 1 to the horizontal. Now, we are resolving for our vertical component. So what is it going to be? It is going to be what? F1 sine theta 1. Why? Because we are resolving for our what? Our vertical component. So we use sine. For our horizontal component, we use cos. All right. Now, you must take note of that. And because the angle is inclined to the horizontal. Now, the next one is what? F2. Now, it is going to be minus F2 sine theta 2. Why is it F2? Why is it minus F2? It is at the negative part of your y-axis, and you are resolving for your vertical component. It's at the negative part. So it's minus F2 sine theta. Now, F3 is also at the negative part of your y-axis. So it's going to be minus F3 sine theta 3. Now, the next one is going to be what? F4. So it's going to be what? Plus F4 sine theta 4. Because what? It is at the positive part of your what? Of your y-axis. All right. Now, after we get these values, to now get the final resultant of all these forces, it is going to be the square root of the horizontal component squared plus the vertical component squared, while the direction, the magnitude of direction will be tan inverse of what? Your vertical component over your horizontal component. All right, so please take note of these formulas. All right, take note of this. So let's go ahead and solve a question on this. A force of 10 Newton is applied to a block of wood as illustrated below. So this is the block of wood on a ground, and a force of 10 Newton is pulling it, and the angle of inclination to the horizontal is 30 degrees. What is the vertical component of the force? Now, the vertical component of the force, is simply going to be what? 10 what? Sine 30 degree. All right, because this is the force and the angle of inclination to the horizontal is 30 degree. So the vertical component is going to be F sine theta, because the angle is inclined to the what? Horizontal. All right, so now it becomes what? 10 times sine 30 degrees what? 0.5 or 1 over 2. All right, 0.5 or 1 over 2. So 10 times 1 over 2, that's 2 year 1, 2 year 5. I mean, you have 2 year 1, 2 year 5. Your answer is going to be simply what? 5 Newton. All right, so the horizontal component is 5 Newton. Now, let's go ahead and solve a question on forces acting, more than 2 forces acting at a point. All right, so let's solve this question now. The figure above shows 4 forces, 3 Newton, 10 Newton, 3 root 3 Newton, and 6 Newton acting on a particle P. The resultant of the 4 forces is, so we have these forces acting on this particle P. Now, let's say this is our F1, let's say this is our F2, let's say this is our F3, and let's say this is our F4. So we have 4 forces here. Now, we know that we have to resolve them into the horizontal component and the vertical component. So let's resolve them into the horizontal component first. So resolving into the horizontal component, let's say HC. All right, what's it going to be? Now, F1 is directly on the vertical axis. All right, it's directly on the vertical axis. So it's not going to be irrelevant. Yes, let me put it like that. And do not forget that this is your what? Positive x, this is your negative x, this is your what? Positive y-axis, and this is your negative y-axis. So for our horizontal component, now that we're resolving this, for this F1 force, it will not be relevant because it is acting directly on the vertical axis. And do not forget, we are resolving for the horizontal component, so it's not going to be relevant. Now, let's go to the next force. The next force is 10 Newton. Now, we want to resolve this force to the horizontal component. The angle of inclination to the horizontal is 30 degrees. So this is going to be what? 10 what? Cos 30 degree. Like I said, we always use cos for our horizontal component, and it is also on the positive part of x. Now, this is F3, 3 Newton, and it is directly on the horizontal component. So, and it's also on the positive part of x. So it's just going to be plus 3. We don't have to give it any angle, all right? Because it's directly on the horizontal axis, all right? And it's on the positive side of the x-axis. Now, going to this force, F4. Now, let's deal with this force. This force is on the negative part of x, all right? It is on the negative part of x. So it is going to be minus what? 6. The angle of inclination to the horizontal is 60. So it's going to be minus 6 cos 60 degree, all right? So our horizontal component is going to be what? Cos 30 degree is what? Cos 30 degree is root 3 over 2. So it's going to be 10 times root 3 over 2 plus 3 minus 6. What is cos 60? Cos 60 is what? 1 over 2. So it's going to be what? We're going to have what? 2 goes here 1, 2 goes here 5. So 5 times root 3, that gives us what? For the horizontal component, we have 5 root 3 plus 3. Now 2 goes here 1, 2 goes here 3. So we have minus 3. So this is going to be minus 3. Now everything here, 3 minus 3 is 0. We're going to be left with 5 root 3. All right, 5 root 3 Newton. Now let's go for the what? For the vertical component. All right, let's go for the vertical component. All right, this is for the horizontal component. Let's go for the vertical component. So for the vertical component, what is it going to be? Now, this is directly on the vertical axis, and it is also on the positive part. All right, so this is simply going to be 3 root 3. We don't need to allocate any angle to it because it's directly on the vertical axis. Take note of that. Now, the next force is 10 Newton force inclined at an angle of 30 degrees to the horizontal. Now, let's resolve it as a vertical component. What is it going to be? It is going to be what? Plus what? 10 sine what? 30 degrees, because it's on the positive part of our y-axis. All right. Now, the next one is our 3 Newton force, but it is directly on the horizontal axis, the x-axis. All right. Now, it's not going to be relevant because it's directly on the x-axis, on the horizontal axis. So we don't need to give it any angle. We don't need to allocate any angle to it, and it is also not going to be relevant because we are sorting out for our vertical component in this case. Now, the next one is our what? F4, which is 6 Newton, the fourth force. Now, it is on the negative part of your y-axis. All right. So what's going to happen? This is going to be what? It's going to be minus what? It's going to be minus 6 what? What's the angle of inclination? 60. So it's going to be 6 sine 60 degree. Minus 6 sine 60 degree. So this is going to be what? 3 root 3 plus what is sine 30 is 1 over 2. So this is going to be 10 times 1 over 2 minus 6 times sine 60 is what? Sine 60 is what? Root 3 over 2. All right. So what's that going to be? That's going to be what? 2 here 1, 2 here 5, 2 here 1, 2 here 3. So this is going to be what? 3 root 3 plus 5 minus 3 root 3. Of course, plus 3 root 3 is going to take away minus 3 root 3. You're going to be left with 5 what? Newton. So we now have our horizontal component and our vertical component. Now, let us finally find the resultant. We've resolved this into our horizontal component, which we got what? 5 root 3 Newton, and for the vertical component, we got 5 Newton. So now let's now get the resultant now that we've resolved it into the horizontal and vertical component. So now we now have that our vertical component was resolved to 5 Newton and our horizontal component was resolved to 5 root 3 Newton. Now let's get the resultant and the direction. Now the resultant, like I said, is going to be square root of what? X squared plus y squared. So this is r is going to be equal to square root of what is your horizontal component? 5 root 3 all squared plus what? What is your vertical component? 5 squared. Alright, so your resultant now is going to be equal to what? Square root of this square, alright, is affecting 5, so that becomes 25, and then the square is also affecting the root 3, so but the square will cancel the root 3, so you are going to have 25 times 3 plus 5 squared gives us 5 times 5, that's 25. So our resultant is going to be what? Square root of 25 times 3 is going to give us what? 75 plus 25, that's going to be square root of what? 100, and square root of 100 is going to give us 10. So square root of 100 is 10. Alright, now let's get the direction. We were not asked to find the direction, but let's go ahead and find the direction. So our direction theta is going to be tan inverse of the what? Vertical component over the horizontal component. Alright, so theta is going to be equal to tan inverse of what is our vertical component? Our vertical component is what? 5 over what's our horizontal component? 5 root 3. Alright, so now 5 is going to take away 5 here, so we're going to be left with that theta is equal to tan inverse of what? 1 over root 3, and tan inverse of 1 over root 3 is simply 30 degree. Alright, so our resultant is 10 Newton and our what? Direction is 30 degree. Now make sure you like this video, share this video, and subscribe to my YouTube channel for more amazing and educational videos like this. Thank you.